robotics, let's talk about push buttons. It's our next topic here because this is actually something that is very cool. It's at this point you've hooked up an LED, you've proven that you can actually make the electricity flow, but now we want to control it. And that's really what electronics is about, is how do we control the electricity moving? How do we actually make it move in the way that we want to make it move? So let's hop over really quickly to TinkerCAD here and let's see what we've got set up. All right, here we are in TinkerCAD. My parts move away. All I did is I took the parts from the LED exercise and I've added a push button. Now let's talk about the push button here. TinkerCAD actually does a really good job of explaining the push button. So let's zoom in on this guy. Now this is what's called a momentary push button, and it's a normally open momentary push button, which means that we're going to actually we're going to close it. We're going to actually turn it on when we push the button. They do come in both kinds depending on your application. There's a few other versions of this, by the way, that are basically the same, including things like slide switches. And I think we'll actually hook up a slide switch here too, just to learn how they work. In both cases, these are going to stop or start electrical flow through the part when we do something mechanical. So the term we'd often use is a mechanical device here. We're going to actually move this in some way and we're going to change the electrical flow. Now let's take a look at this push button. We've got terminal 1B, 1A, 2B, and 2A. What that means is that terminal 1, the left side here, is electrically connected right now. If I went ahead and actually hooked up an LED circuit, very simple LED circuit here, we'll hook it up on this side, and I just used terminal 1A and 1B here. Let's actually hook this up. I'm going to hook my resistor up there. I'm going to hook my push button up there. I'm going to hook terminal 1A to negative in this case because it's on the flat side of the LED if we look there. Then I'm going to hook the other side up to positive. Now I have an electrical circuit. Voltage is going to flow through here, should flow through the push button, through the resistor, back through the LED, and back out through the positive voltage here. Easy enough. And since I've already actually wired up my breadboard over here to actually work on both sides, this is actually going to work. So we're going to turn around, we're going to start our simulation, and the LED is going to turn on. And no matter what I do to push this push button, nothing is going to change. And it's actually doing what it's supposed to do, believe it or not. So let's actually make this thing work, because what's happening is terminal 1B and terminal 1A are normally electrically connected. They were behaving exactly how they were supposed to be. When I press this push button, what actually happens is it connects terminal 1B and 1A to terminal 2B and 2A. All four of these legs are going to become electrically connected with one another when I push the push button. So what I actually wanted to do is I wanted to make an open circuit. I actually wanted to start this circuit so the electricity couldn't flow. Because right now, I look at the electricity, terminal 1B and 1A are not connected to anything except this one resistor. The electricity really has nowhere to go, and likewise the electricity coming out of the negative lead here goes into terminal 2A and it has nowhere to go. But the moment that I turn and I push this push button, suddenly the electricity flows through all of those things. This whole thing becomes electrically connected, makes a beautiful electrical circuit, and we get light, and we get control of how this works electrically. Now let's talk briefly about how this works with the slide switch, because the slide switch is very similar in how it works. I'm just going to put my slide switch on here, and we're actually going to play with a version of this on the in the real life version. I'm going to move my push button over. I'm just going to delete this. I don't really need it. And what I'm going to do is I'm going to take my slide switch, and I see that I have terminal 1, and I have common, and I have terminal 2. Now how this works is that terminal 1 right now is actually connected to common. Okay, they're actually connected because of where the switch is. But as soon as I move the switch over to the other side, those two are going to become disconnected, and terminal 2 and common are going to become connected instead. So basically I'm shifting, if we labeled these pins 1, 2, and 3, right now pins 1 and 2 are connected together. And when I flick the switch, pins 2 and 3 are going to be connected together. But guess what? I'm not going to connect anything to pin number 3. I'm just going to connect the negative voltage to pin number 2. What that means is that when I start my simulation, the LED is going to turn on, but I'm going to flick the switch to the other side, and right now that voltage is coming through negative, it's coming through the slide switch, and it has nowhere to go. There's no complete circuit here, and therefore I have control of the light switch, which is amazing. Now let's talk about the real world version of this. Let's hop over to our breadboard and actually take a look at what we've got here. All right, so I've laid out the basic stuff from our initial presentation. We've got a battery, we've got our powered breadboard, life is good, it turns on, LED works. Life is good. Now, we've got our push button here. The ones that come in most Arduino kits, they come with a button top and they come with the push button itself. Some will come with a really small push button. The smaller the push button, the harder it is to make work. Usually the top of this just snaps on here to create a really happy tactile feel for something that does a nice little click motion. I'm going to put that one off on the side. I've actually already taken my push button and I've actually put it onto my board, the one that I'm going to use. And I want to make note with these ones that are on the breadboard, you actually really need to push these into the breadboard to get them to stick. If they're not quite in the breadboard, the legs aren't actually touching metal, therefore there's no electrical connection. I'm going to leave the top off of this one for just a second while I hook up the circuit, but you're more than welcome to put it on there. Notice that I've got legs that have one space of gap in between them on both sides. And I know that on my left here I have the 1A and on the right I have the 2A and B by that matter. Let's take our LED and let's hook up our LED. I'm just going to take a quick look at this to find where the flat side is. And the flat side is on that side right there. So I'm going to go ahead and hook the LED in here. Okay, I'm going to take my resistor. I'm going to do exactly what we did in the LED section. I am going to hook it up into the same terminal strip as the LED. Okay, I'm actually going to run mine back this direction. Make sure your leads don't touch when you're doing this, but there is nothing stopping you from putting things together in pretty tight quarters. If I touch the lead here and if I actually touch this LED to the other side of, or this resistor lead to the other side of the LED, I might be in for a bit of trouble there. That wouldn't be too good. Now what I'm going to do really quickly, I want to try something here. I actually have a bit of a zoomed in version for just this part, and I know the resolution is not ideal, it's not perfect here, but I think we can get a better view of exactly what we're doing. So we've got our resistor hanging out here, it's connected to our LED, life is good, and then we're just going to finish this off by putting our negative wire right here and into our negative wire. Now, alternatively, you guys are more than welcome to do this, you could actually take this and you could just run the resistor directly into the negative terminal strip. So what that looks like is this. I'm just going to use my pliers to put this in a little further because this one's a really small resistor. There we go. Okay, all the way in. Okay, we can do that. There's nothing wrong with that as a circuit. And that resistor, I know the zoom is not great here. There's a little bit of poor resolution on this one. It is what it is. That resistor is actually sitting into the negative power or terminal strip. No, terminal strip, power rail. There we go. On the top here, you can't really see it, but I'm going to line this up with my in this case my 1B according to our TinkerCAD, and I'm just going to actually zoom this back out here so we get a decent look at where all this is going. Then I'm going to run this into my positive power rail on the top there, and we're going to turn this on. Now, luckily yes, we don't see anything getting pushed. There's nothing actually turning on here, but when we push this push button, we should get, and I'm just going to go line this up, and I can actually see from where I'm sitting that I've got a working LED, and I'm just going to go in here, and we have a working LED when we push that. Okay, this is the exact circuit we just did in TinkerCAD. Now, I want to show you another part here while we're talking about push buttons, and one of the things that this is actually a part that works very much like that slide switch we just talked about. I'm just going to work this out of here and pull the push button, but I'm going to keep the rest of this circuit here. There we go. That little pop out of there. We've got it nice and tight in there, which is probably how we needed it to get a good electrical connection. All right, what we're going to do is we're actually going to introduce a new part, and this should be in most of the kits, the Arduino kits that we have. This is actually a capacitive touch sensor, and this is actually something that is used all over the place, including often in like cell phone screens and things where you just want to get a nice little touch and actually have something function. So what I'm going to do on this, I'm going to look on the board itself, and I can see, resolution's not going to be great on this one, but I can see right about here on your board, I can actually see three things written. And the three things that are written here are actually going to be VCC, which represents positive voltage, or your 5 volts in this case. I can also see ground, which is on the left, and that's obviously going to be our negative voltage, our black wires in the case of TinkerCAD. And I can see SIG, which is signal. So what I'm going to do is I'm actually going to go ahead and just straight up hook this up to signal, and I'm going to put signal where I have my LED. Okay. Now I'm going to grab those two wires that I had before, and I know that I've got VCC in the middle. Notice that even though I have some wires dangling here and I happen to be touching stuff on my board, I've turned the power off. This is a good thing to do so that you don't short anything that you're not supposed to short, because that would be bad. It's not a good idea to put electricity where it's not supposed to be on a breadboard, or in any electronics project for that matter. I'm going to connect this wire up to positive, and grab my green wire here. I'm going to put it into the breadboard right here. And as long as things are electrically connected, it doesn't matter as much exactly where they are. Now, So I'm going to take these wires and kind of move them out of the way so that they're not getting in the way. I'm going to press the power button here, turn this on, and I'm going to try my capacitive touch sensor. What you can see there is, just by getting close to this, okay, I actually am activating that capacitive touch sensor. And this is the same way, like I say, that a lot of things like cell phone screens and some other electronics actually work. So there's a couple things you can test out in terms of controlling electricity with mechanical motion, or in this case capacitive touch sensing, to actually make your breadboard function. Go enjoy, play with this, and remember that the electronics here are a playground. Try new things, see what you can do, because that's part of the fun of this thing. Enjoy.